Back when mathematics was invented, this is how they used to do calculus. They used to take a lot of derivatives to find the velocity the position gives, and then they figured out what the constant is. But sometimes it rises and sometimes it dips, and when it dips, the negative slope of f is down. But when using polar graphs, you just go around the y-axis. You're beginning to think you have it, but then you are asked to graph it, and all breaks out in havoc. In a couple of minutes, you get in there and finish it. You move to the next topic and start to take limits. When you end up with infinity over infinity, 0 over 0, use the Hobbitall's rule for these. And when solving integrals, proceed cautiously, because using u sub will change the limits promptly. Next, you can use trapezoid rule to find the area under the curve, -2. Or you can take the derivatives of f, then find the critical points by solving for 0 again. Use a symbol to find a perfect time and horizontal line for the slope. The function has been optimized. I'm going to a quiet place now to find a rate of change. Taylor's theories are strange, because every time I try to go to solve this math problem, I just hit a wall. I really think I need to learn more. But now I am through with this course. So when I study all this next year, maybe it will become more clear. And then I'll be able to solve this problem that I'm working on. In the fourth quarter, all we used to do was find sums of series and test convergence too. Just a few weeks later, and we're finally through. When we were engrossing it, we used to use the root test to check for convergence, and then if it failed, we change test and check again. You can start wherever you want, for whatever you want, whenever you want, however you want, with whoever you want. However, there do seem to be certain schemes for choosing the right test, like if you see limit as n goes to infinity is equal to 3 by the nth term test the divergent series, or if you decide to use the limit comparison test, which is only helpful when a convergent is lesser, divergent is more than the series that you're trying to test, but when used with natural log, it's completely useless. But in the long run, volume problems may be the most applicable to everyday life. And to solve one, find the lines that just outline the cross-sectional area of the object you're trying to find. To wrap around the axis directly in the middle. When using a real object, it may change a little. Parametric curves use two different equations. Use a slope field to graph without hesitation, because every time I go to try to solve this math problem, I just hit a wall. I really think I need to learn more. But now I am through with this course. So when I study all this next year, maybe it will become more clear. And then I'll be able to solve this math problem that I'm working on.